Alright, hi everyone. So this is the revision video for topic 3, which is coordinate geometry. So there are actually quite a lot of content that we learn under this chapter. So we are going to make a very quick revision. Okay, so the first thing when we first started this chapter, we learned about the length of the line segment. Okay, so the length of a line segment and also the midpoint. Alright. Okay, so if let's say we have 2 point on the coordinate, meaning if let's say I have one P which is x1 and y1, and I have the other point which is Q, x2, y2. Okay, so for me to find the length of PQ, so I'll be using the formula square root x2 minus x1 square plus y2 minus y1 square. Okay, this is like a Pythagoras theorem, as you know. Okay, so then after that, the second part is for the midpoint. So if I want to find the midpoint between P and Q, then I will use the formula for midpoint. For me to get PQ is actually for x coordinate, it will be x1 plus x2 divide by 2, and after that y1 plus y2 divide by 2. Okay, so this is the formula to find the length between 2 points and also the midpoint. Then the next thing that we learn is gradient. Okay, so if we want to find the gradient between 2 points, then we'll be using the formula gradient equal to y2 minus y1 divide by x2 minus x1. Okay, so it's the same thing as well if you try to do 1 first, meaning you are using y1 minus y2, but just make sure that if you are using 1 before 2, which means for your x coordinate it has to be 1 first, then after that continue with 2. Okay, then the next one we learn about parallel line. So if let's say we have 2 lines here, which is this is line 1 and this is line 2, and if they are parallel, then we say that the gradient for line 1 will be equal to the gradient for line 2. Okay, so the last thing is about the perpendicular. So if let's say we have 2 lines that is perpendicular to each other, which means if let's say this is 1, this is 2, then we will have the formula m1 and 2 will be equals to -1. Okay, so this is for perpendicular. So after we have learned about gradient, then we use it in what called as equation of straight line, right? So equation of straight line. So there are few types of equation for straight line that you can use or apply. So the first one is the the easiest one, which also I think the most familiar for you guys, which is y equals to mx plus c. Okay, which you know that m is actually the gradient, then after that c is your x-intercept, correct? So this is y equals to mx plus c. Now after that, the second one is you have y minus y1 equal to m, then x minus x1. Okay, so for this one, you also need the gradient, and you need one coordinate, which it can be any coordinate on the line. Okay, so which is the y1 and which is the x1 and y1 that you substitute in this formula. Then after that, you have your third type, which is what we call as the intercept form. So which is in the form of x over a plus y over b equals to 1. Okay, so in this form, you can see that you have x, y, and ab. So a actually stand for your x-intercept. Okay, so the constant below the x is your x-intercept. Then after that, the b is your y-intercept. Okay, so this is the intercept form. Then after that, for the fourth type, is actually not one of the equation for straight line, but it's just that if let's say if you have a graph that is parallel to your x-axis, then your formula for this straight line will always be y equals to a, right? And a is just the intercept for your y-axis. Then after that, for your number 5, which you have a line that is parallel to the y-axis, then the formula here will be x equals to a. Okay, so it's the same thing lah. So this one you are using your y-intercept and this one you are using your x-intercept. Okay, which I think you should be quite familiar with this. So the only thing that you might be forgetting is the number 3 one. Okay, so after we have learned about the straight line, then the next thing that we see in this topic is actually equation of circle. So equation for circle. Okay, so for you to find the equation of circle, there are two things that you need to know. So the circle is the equation of circle is in a form of x minus a squared plus y minus a squared equals to r squared. Okay, so what is a, sorry, I have two a here, it should be a b, y minus b squared equals to r squared. Okay, so r is just the radius. Then after that, a and b will be your center. Okay, so these are the two information that you need when you want to form an equation of circle, which means if let's say this is AB and you have a radius of r, then you will just substitute everything into the equation and that will be your standard form for your equation of circle. So on the other hand, after you have the equation of circle, if you try to expand everything out, right, then you'll be able to get something like x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Okay, so this is the part where if let's say you are given this kind of equation, how do you actually determine the center and the radius for your circle? So you need to rearrange them. So meaning that you put the x term together, okay, put your y term together. Then after that, for your c, you can just move it to the other side. So now what do you need to do? You need to do completing the square. So x squared plus 2gx, after you do completing the square, and you will be able to get x plus g squared minus g squared, right? 2g divided by 2, you get g. Then at the same time, for the other side, you have y minus f squared minus f squared equals to negative c. So when you try to rearrange the whole thing, right, you will have x plus g squared plus y minus f squared equal to g squared plus f squared minus c. So you can see that now it's in a form of equation for circle, which means g will be your, which means like negative g lah. Negative g will be your x coordinate for your center. So this should be plus. Okay, and then for f, then it will be negative f, then it will be the y coordinate for your center. Then after that, your radius will be equals to g squared plus f squared minus c. Okay, so you need not to actually memorize this formula, but this is for giving you an idea of if you are given the general form for a circle, how do you actually find out the center and the radius from the general form of equation. Okay, then the next thing we are going to look at three properties for circle. So this will be helpful for you to solve some of the questions. So the first one will be, if let's say you have a circle and this is the center, right? So if you actually have one tangent, so tangent is a line that actually touch the circle at one point only. And if you try to draw a line from the center to the point that the tangent touch the circle, it will actually form a right angle. Okay, so which means the tangent and the radius will be like perpendicular to each other. So this is very useful if let's say you want to find out what is the equation for the tangent, which means you have your center, you have the point, then you can actually find out the gradient Then after that, using the properties of m1, m2 equals to -1, then you can find the tangent, the gradient for the tangent. Then by just substituting the intersection point here, then you will be able to get the equation for your tangent for the circle. Okay, so the second one is that if let's say you have a triangle which one of the side is the diameter of the circle, then when you try to draw another two line that touches the circle, right, it will always form a right angle triangle. Okay, so in another word, the angle in a semicircle is a right angle. Okay, which means after you have draw a semicircle and you try to draw two lines that substituted at the circle, then you will be able to get a right angle. Okay, then after that, the third one will be if let's say you have a chord. So this is your center and this is a chord. Okay, so a chord is a line that touches the is a line that touches the circumference of the circle at 2 points. So which means this is a chord. So when you try to draw a line from the center perpendicular to the chord, then you will be able to get a perpendicular bisector. Okay, so perpendicular line from the center, perpendicular line, okay, from the center, from center to the chord, bisect the chord. Okay, bisect meaning that it actually divide your chord into two equal part. Okay, so that's the idea. Alright, so this is some of the properties that might help you in solving your questions. Okay, so for the last part, it's actually a very short one, so I'm not going to talk about it like very detailed because we have covered it in a quadratic as well. So this is just a reminder for you that the content about the intersection of line and circle and also the line and the curve as well. Okay, so if let's say you want to find out whether there is an intersection between the line and the circle or not, then you will need to do your simultaneous equation, right? So you will need to substitute, then after that you get your answer. Then after that, same thing. If you want to prove that whether the line and the circle is intersecting each other or not, meaning that you are actually finding out whether there is a solution or not for your simultaneous equation. So that's why when you want to prove it, then you will be using b squared minus 4ac, okay, which greater than 0, meaning that you have distinct, so two distinct, yeah, let me write down, two distinct intersection point. Okay, I just write IPT, intersection point, okay. Then after that, if let's say equals to 0, which means that you have one intersection point. Okay, so if let's say you have only one intersection point in another hand, it also means that the line is actually the tangent lah. So because only the tangent line will touches the circle at 1 point, so that's why if let's say you have 1 point only, which is like two repeated routes or like one repeated route, two similar routes, and which mean that the line is a tangent. Then lesser than 0, which mean that there's no intersection point. Okay, so this is like the whole content that we have learned under the chapter for coordinate geometry. Okay, so all right, that's it. Thank you.